Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're really excited to bring to you, we're going to look at some data science tonight and TI technology. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make a lot of concepts accessible to all my students. And with us tonight, we have two experts in the field of data science, and that's Gail Burrell and Tom Dick. They're both national instructors. They've both been in education for a very long time. Amongst many accolades for Gail, I know that she's the past president of NCTM. And I believe Tom has been inducted into Oregon's Math Teachers Hall of Fame. So thanks so much to the two of you for joining us. I really appreciate it. We're excited to get things started tonight.
We're happy to be here, Mike. Thanks.
Very happy to be here.
And Tom, would you mind talking through what the plan is for tonight?
Sure. Yeah, once we get done with these introductions, we're hoping to share with you tonight a little bit of an introduction to data science, what it's all about. And Gail will start us out by looking at some census data at school. And then we'll go into looking a little bit more about what the whole data science field is, the process for doing data science, and some principles that Gail and I developed as we developed activities that guided us into how to design activities that can engage students. Then we're going to look at some, we hope you'll find some really interesting data about the changing climate, including some special TNS documents that let us explore risk index of climate by the states. And I'll turn it back over to Mike at the end for a webinar drawing.
Tom, thanks so much. Yeah, be sure everyone can stick around tonight. One lucky winner is going to be receiving a TI graphing calculator of their choice. Gail, would you mind talking through a couple things that we hope people are going to be able to do at the end of the webinar tonight?
So tonight our goals are to actually help you guys think about what data science is, come to be familiar with a framework for the data science process, and how we can implement that framework using TI technology, build some understanding about some activities involving large data sets and how we might approach those using TI technology, identify some data moves that are necessary when you're working with big data and the data science process, and then think just a little bit about some way that data-driven activities can be incorporated into your classrooms.
Awesome. Thanks so much, Gail. We're expecting a large crowd, so your audio is muted. Feel free to send any questions you have for Gail or Tom using that Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the event. So let's get things started. Tom, let me give Tom control. Feel free to share your screen, Tom.
All right, I'm going to go over to PowerPoint that Gail and I'll be using for the first part of our session tonight. See if we've got that set up, and let me make that a little larger.
So while Tom is getting that set up, we're going to start by looking at some data from the Census at School project. I don't know if you've heard of this. It's from the American Statistical Association. It is an enormous set of data. You can go to the next one, please, Tom. There are 60-some variables that have been collected from across the United States. There's actually an international data science Census at School project. And so you can get international data there for kids from, I think, maybe 4th grade through 12th grade over the years. Because they are volunteers who fill these out, there's lots of interesting things to think about. But it's free, it's downloadable, and it's a great way to get your kids started in thinking about working with larger data sets. So I would suggest that you get them looking at that and just explore around. And we're going to look tonight, next one, please, Tom, at just something that I picked out. So what are you curious about for your students? What do you notice? They can just like, they could do if they have their own access to a computer, or you could just scroll through it and show them the different things that they could look at. I don't think I would put them on a piece of paper and hand it out because there's an awful lot of them. Next slide, please, Tom. So I just picked a question, and one of the things you want to be careful about when you do with data science is that kids often try to pick a question that can be answered with a single number or just yes or no, like what's the mean age? Well, that's not a real investigative question. You just calculate the mean and you're done. So you want something a little more interesting. So I just kind of arbitrarily said, let's look at males and females. And look at some certain characteristics about that these kids have reported. Next slide, please, Tom. And the data are messy because the kids put them in there. There's blanks. They fill them in with, you don't know how, where that kid got the W from. All of a sudden, there's a decimal in the middle of these numbers. You're not sure if that's a legitimate one. The one that's underlined in blue down there, that's a number of hours. We've got this kid is working 330 hours a week doing different things. I'm not sure the kid knows how many hours in a week there actually are. Next one, please, Tom. So I started off intending to do this on the 84, and unfortunately, and I apologize for this, my emulator kept crashing. And so after about 6 tries, I decided that I was going to have to do something to fix my emulator. Didn't have time to do it. So I'm just going to talk through what this would look like on an 84. There are a couple of things that are data moves across, whether we use the Nspire or the 84. That has to do with units and magnitude and blanks and outliers. But there are specific things for the 84. For example, you can only use 5 letters when you label one of your data sets. So you have to have a strategic way to pick the letters so that you remember what those things are. The 84 does not take words. You cannot use letters in putting in data. So if you have categorical data, you have to code it. You have to find a numerical code. So one of the questions or the pieces that I looked at was the favorite subject. So I have to code that to put that into the 84. Next slide, please, Tom. And so here's a couple of slides from the Nspire, but you will see the same kind of thing. Problems with what do you do with a lot or none? On the 84, you're going to just run into a blank. It's not going to take that. So you have to figure out how to deal with this. Notice that slide down there in the right, the lower right. There's clearly some outliers, those 220 or 30 and 140. You have to figure out what you're going to do with that. Next slide, please, Tom. You can see an example in the upper right of how you have to be careful. So that first line means male texting. So that's the number of hours that the males text. And the next one is the number of hours that the males work on a computer. And so there, you have to pick this really carefully. The Census at School actually has a filter that you can use. So you can filter it and just look at the males or the females or whatever category you want to look at. So that's kind of nice. I was able to use that. Next one, please. And here's just some of the things you can do. All of these things except the favorite subject. As I said, that would be a list of 1s or 2s or 3s. Like a histogram with just a 1 is what it would look like. You can make 3 box plots. You can make 3 histograms. And you can make scatter plots. So you can do some investigation of the data once you get it entered in. Next slide, please. And once the kids have explored and looked at the different kinds of questions and looked at different ways of putting the ideas together, they want to build some kind of a model that will help them answer the question. And when you build these models, you have to be really careful about the units that you have, and you also have to be very careful about the magnitude. And so here in this case, they were rating the importance of owning your own computer, and that went on a scale from 0 to 1,000, which was much larger than the number of hours that they worked on their homework. So this was something I had to take into consideration. So I just did a mean for each of the categories for the males and females. And then I made the ratio of the males and the females to the total number, the mean of the total overall different number of hours. and created a weighted sum, and I just decided how much weight I wanted each one to have. I accounted for the 1,000 by dividing by 100 to get it back down into some kind of a range that would be sensible. And your students will have different ways to do this, and that's perfectly fine. That's what this is all about. Next slide, please, Tom. And one of the really good ways to do this is they can actually, after they write up their story about what they're finding when they're doing this investigation, they can look at each other's stories and models and see if they would work in terms of what they were doing themselves. So they can actually try this other people's story, other people's models, and see how that would work. Next slide, please, Tom. And then you could either start like this, or you can end by having them do their own data collection about the same variables and compare it to the results they got when they looked at the variables that they chose from Census at School. So I don't know if you have any questions. If you do, please post them so we can answer them. But this is one way that you can actually just get kids introduced to playing around with big data sets. Next slide. So what is data science anyway? So the very simple definition is it's the science of learning from data. And not really an agreement about what data science is. The experts across all the different courses that are at the university level, and many of them are starting to pop up in high schools, is that it's a combination of understanding something about statistics, understanding something about mathematics, although not as much as you might think, knowing something about computer science, having some limited, at least knowledge, working knowledge of how to do things with programs, and knowledge of a discipline. And so it's this kind of intersection of these three things, four things maybe. And it's basically about uncovering the stories within the data. And it involves this thing they call wrangling with data, trying to interrogate the data, trying to figure out what the data is telling you about some particular thing. And it does involve a lot of computational thinking. That's kind of the way you mostly get your models. Next slide, please. The difference between data science and statistics. So statistics is basically, it uses mathematical models to quantify relationships and make predictions, but the statistics has usually been kind of driven by inference and different tests of hypothesis and things with small, clean data sets. And data science is very much larger. The data sets are collected not on purpose to design an experiment, but they're collected by some company who is interested in finding out how many people are tapping into something, or the government is collecting all these data sets. So they're just big and totally kind of unstructured. And you don't start from a question, kind of, you have this big data and you're like, okay, what might be interesting to me in this big data set? Next slide, please. And there's a process that this comes from a kind of combination. Tom and I kind of derived this from a couple of different formula processes, different ways that people have thought about this, but you start with the problem and it's very clear you end with some kind of a solution to the problem. So you don't just start with a problem and then calculate a couple of the statistics or something like that. You actually have a question that it's driving your work. I prefer to start my students with pretty tidy data sets. Census at School can be small enough. You can pick a sample of size 50 or 20 so that you can really talk about it, or you can pick a sample of 500, whatever you want to pick. And get the students just noticing and wondering about what's going on with those data. You have to clean and sometimes transform the data. You want kids to spend some time exploring what numerical measures might be useful, what graphs might be useful, and then they develop their model and communicate something. Thanks, Tom. Next slide. So Tom's gonna tell you a little bit about the principles that guide this.
Okay. And I really owe most of this effort for articulating these principles to Gail. we found as we were working on activities, we had saw a pattern to what we were doing, and Gail articulated these principles. So it's really good to start with informal before formal, just looking at the data and with the students, that standard question of what do you wonder, what are you curious about is excellent to do with data sets. Formal definitions or definitions of particular types of data, those things should be delayed. You should those should appear to be developed through the context before you unveil. There's some standard terminology that's used in this context. Laying that stuff out at the very beginning. Scaffolding is certainly important. Simulation, that's something where we've really found the technology is a tremendous aid, is because the simulations that you can do, moving from kind of a hands-on simulations where you might be using something like dice or drawing cards from a deck, to turning that over to the technology where you can ratchet up the you can have a number of draws or something like that. It is really handy. Reasoning from sampling distributions, using visual displays of data. These are things that we're looking at, and again, especially visual displays as well as sampling distributions. The computing power of the technology is very helpful. And this last thing is not to be neglected. Is after you've done an exploration, is to look at how do you communicate what you found. What are the new questions that arose? How can you connect this to other questions or other data that might be reported in the media or related to other areas of mathematics? So these are principles that have guided us in the work we've been doing and creating some activities for students and for teachers to use.
Thanks, Tom. And I will add, oh, go ahead.
Oh, I was just going to say it's a lot on that slide, but taking the time to look at where this stuff fits in the curriculum, what kinds of previous knowledge you want students to have if you're embarking on certain data moves or uses of statistics. Belabor that slide much as well. Go ahead and move on to the next. I'm going to let you go with this.
Okay. So in the kind of the same sense, the Census at Schools is a relatively simple, easy way to get kids into thinking about data and formulating a question. And I do have to say, I often forget about the question and the answer to the question because I get caught up in looking at the data. So it's a really important part of the process. So one of the things that Tom and I were thinking about was the climate change. And we did some work, some of you may have seen that, with the CO2 levels, which is available on the TI website. And that was really fascinating work. And so we added on by thinking about the climate. And I mean, this is something that is, it's around and everybody knows it. It has different kind of embodiments of what it looks like, but we're all pretty clear there's something happening with our climate. And so we thought this would be another place that we could do a little bit of research and play around a little bit with some big data sets. So next slide, please, Tom. So with that, maybe we would look to compare states with respect to climate change. So how do states compare? And so we found some data, next slide, that actually gave us information about all the states. And I kind of arbitrarily picked Utah, Oregon, Louisiana, Texas, and New Jersey. And I restricted what I was looking at to keep this relatively simple right now. So I just looked at the maximum temperature, the average temperature. They have a drought rating, and the drought rating pretty much goes from maybe -7 to 7, where -7 is a severe drought, and excuse me, and 7 is very moist. And they get that drought rating by doing some computations about the makeup of the soil, how much humidity or moisture is in the soil and so on. So they have these technical ways that they go about calculating that. And then the amount of precipitation in each of these states. And it goes all the way back to 1895. So you've got this data that you're going to look at to see what's going to happen. Next slide, please, Tom. These data were not too messy. You had to understand them, but they were kind of complete. So I didn't have to go filling in or worrying about zeros. Excuse me. Here's the average temperature by state. So it looks kind of messy, and that's okay. The thing that I thought was interesting here is that New Jersey and Louisiana have a much higher average temperature, which I guess isn't surprising, but maybe it is, than Texas or Utah. Oregon, I wasn't surprised that that temperature was where it was, but I was pretty surprised that Texas's average temperature was as low as it was. And you notice that the change in the temperature is pretty slight, as you see the slope upwards. Next slide, please. So just exploring these data, trying to get to know what's going on. I actually, and you don't really have to pay all that much attention to this, but I'm just looking at different ways that you can look at these data. So this is Louisiana. You can see the maximum temperature, the average temperature, the precipitation, and you can see how the precipitation goes up and down, as well as the drought index goes up and down. So some years Louisiana had a couple of years ago, in about 2015, it had a severe drought, and then it bounced back, and it was went back up to being very moist. So it would be interesting actually to contrast or look at the high points on the precipitation and the drought severity. That would probably be a nice place to do some correlation. Next slide, please, Tom. Here's a New Jersey, and something happened to the slide in the upper corner. He morphed, so there's two of them, but the same information is here that you can look at. Next slide, please. And this is just to kind of show you different ways to kind of get to experience what's happening with these data. So you can see that Oregon, for example, it's got pretty much and this is not surprising, pretty much the same slope for those regression lines for both the maximum and the average temperature. So they're both about 0.024, 0.025. And I guess that would be to be expected. Next slide, please. Utah is kind of interesting. Next slide, please, Tom. If you notice, the last 10 years or so, Utah's been in a pretty extreme drought. So that kind of would show up in, we think, when we're looking at the overall big picture. And their temperature has been rising, again, about the same as Oregon's temperature. But the precipitation has just been kind of bouncing back and forth. Next slide, please. And here's Texas. And Texas is pretty much, it's stayed kind of constant. It's not had a huge gain in their temperatures, which is kind of interesting. Next slide. And as you do this exploring, basically what you really want to start doing is trying to put the ideas together to see if you can see anything that's happening in here that might be interesting in terms of the question that we are looking at. How do these states compare? And so the box plots up there in the upper left-hand corner, those highlighted points are the ones from 2013 to 2022. And that you can see there that Utah, as I mentioned, in the recent years, Utah has had a pretty severe drought, and so has Oregon, actually. Over half of the time, Oregon has had severe drought. And we all think of Oregon and kind of as a rainy state, right, Tom? But this is actually saying that that's really not been the case over the last couple of years. New Jersey, however, has the temperature or the drought and it's been just kind of scattered over. And Texas has had a huge extreme. Some years it's had extreme drought all the way down to -6 practically. And some years it's been up into very wet weather all the way up into 6. So that's just something that you can look at those scatter plots and you can start to piece together some things that are going on with respect to drought in those 5 different states. Next slide, please. So we're still exploring, and in this one, we're looking at the precipitation. And the thing to me that was interesting here is, I know it's a mess, but you can see again that Utah has a very limited amount of precipitation, although it was increasing slightly. Whereas Louisiana and New Jersey have a lot more precipitation per year, all the way up in the 60 inches practically. And it's been fluctuating, but not increasing so that very much anyway. Next slide, please. So here's just looking at the precipitation. And you notice if you look at the slopes of the lines, you can see that Louisiana has about a 0.05. Now that doesn't sound like very much, but it actually, if you think about that, that's like about 5 out of 100, so 1 out of 20. So every 20 years, they get another inch of rain. And if that trend continues, and that's a trend all the way back from in the 1895s, all that way. If that trend continues, you can see that Louisiana is going to end up with an awful lot of rain, which they might not be able to absorb. So it's just kind of putting all these ideas together and trying to figure out how these states relate in terms of this kind of climate crises here. Okay, next slide, please. And so after you've done a bunch of kind of exploration, the next thing is to, again, try to find a model. And so here I'm looking for a model, and this is a really interesting, excuse me, a really interesting set of data, because we've got degrees, inches, and our drought rating scale. And so you've got to figure out some way to put those together, accounting for the units, as also accounting for where we are today in the moving forward process. It's not like we're trying to account for just something that's happened in the past and talk about that. We're trying to say, let's use the past to move forward. And so in our final model, in our thinking about it, we need to find some way to bring in that rate of change that's been happening. And here this is where the computational science part comes in. So when you have all these different variables and you're trying to put them together, coding is the natural way to figure out how to use your formula and what kind of try it out and then tweak it. And so the model that one of the models is to look at the ratio of the mean of the last 10 years to the overall mean, and just simply rank order per variable, with 1 as the, I think I actually used 1 as the not the best, but the worst. So if it was the most severe change, was the 1, got a number 1. A second model would be to set a threshold for danger. So almost all of these climate variables have some kind of a danger threshold. And so, example, if you have too many consecutive heat days, or if the heat goes over 130, it really has a tremendous impact on the ability of people to live in that climate. And so that would be kind of our danger threshold. And you can think about a slope of 0.05% change in per year. And excuse me, if your current maximum temperature is 88 degrees, how many years before you would really reach that danger threshold? And that's where people get this, like, oh, it's going to be 150 years or 200 years. And it all depends on those assumptions that go into that, and that the variability doesn't all of a sudden turn around. But it's pretty clear that we've got data from hundreds of years about how these trends are happening. So next slide, please, Tom. So I used the first model and carried out the calculations, and ended up with Utah is the state that, according to those 4 variables, is at most at risk. Its total ranking came out to a 7, which was slightly lower than Oregon. And so both Oregon and Utah are pretty risky states in terms of these 4 variables about what's going to happen in terms of their temperature and their drought and rain and snow. The other states were not, especially Louisiana. I thought maybe Louisiana would end up being worse, but it really didn't. So next slide, please, Tom. So you want the students to end up writing about that and making some kind of a summary. And now I'm going to turn it over to Tom, and he's going to take it from here.
Okay. So this notion of climate risk, well, first of all, what are the kind of natural events that might be problems? Or, well, there's precipitation, droughts, as Gail touched on. There's the other end of that is too much precipitation. So you could have floods, storms like hurricanes or tornadoes, earthquakes. How do you actually quantify risk and get some kind of thing you can look at in terms of numerical data that's measured in lots of different ways? You could look at actual loss of human lives. One thing I've seen recently is that it looks like economic risk in terms of damage to property is often used for risk indexes. Could be damages to the ecosystem or harm to particular types of wildlife. There's a lot of things that can go into that measurement of risk. These are just some of the things. Gail has touched on some of these, that the effects of kind of extreme climate events, things like fires, and some of it's just the effect, for example, of perhaps changes in precipitation patterns might involve increased mosquito seasons, and things like that. Here is some data, risk by state, where we've got particular identification of impact of climate change. This is some data we're going to take a look at here with the technology in just a bit. This risk index. So what we have here is that we've got a list of all the states. Well, this particular page goes down to Mississippi, but there's a second page of it. And there's this risk index that's been calculated for each state. And that is tied to the prevalence of a variety of different natural disasters: hurricanes, earthquakes, flooding, drought, tornadoes. And what we've been looking at most recently is, are there ways for data like this where we could expand the tools available on the TI platforms that would aid in students and teachers exploring data like this? There's so much data out there that is associated or organized by state. So what we thought to do was to create a map of the states that would be tied in to data in a way that you could use that as to make maps, geographic maps that were tied actually to data. In a couple of the columns here, we've got actually 2 types of maps that could be possibilities. So if you see that second column where it says heat map, a heat map is a map where the map is colored according to the intensity or level of some quantitative variable. So the term heat is owed to the, you often see these kind of maps like in USA Today or whatever on the weather page, where they'll show a map of the United States and you'll see different bands that are colored according to the temperature. A choropleth map, that's the name you see in the top of the third column, that's a map where the color of the geographic regions is tied to some kind of categorical designation. And so for the index, we might want to try to do some kind of a heat map, or just actually looking at which types of disasters are most prevalent in different states. We might use a choropleth map, which would be coloring according to those categories. So what I'm going to do is show you some things we've been working on recently with the Nspire. Oops, sorry. So I'm going to switch out of this PowerPoint and move over to the Nspire. Hopefully see that. That look good, Gail?
Looks
Okay,
good.
great. All right, so let me show you what we've come up with. This on the TI-Nspire, we actually created on a page a map of the United States. So let me go ahead and show that to you. There it is. Okay. So there's the map of the 50 states. The Alaska and Hawaii are certainly on a different scale. Over here, we've got, that's DC, because it's Washington, DC is so small. Got a little blown up view of it. And what we have here is each of these states on this map is actually a polygon. And a polygon on the TI-Nspire, you can actually color it, but you can make the color conditional on the value of some variable. So if that variable is tied to some kind of a data, then it gives you a chance to kind of interactively color such a map. So let's go ahead and look at an application of that. I'm going to move over and show you a list and spreadsheet. And what I have here is in each row, these are the postal abbreviations for each state. So that first one is Alaska, the next one's Alabama, Arkansas, Arizona, and so on. And in the second column, we have the risk index. This is straight from that data you saw on that PowerPoint slide. Okay. So what I'd like to do is actually color that map with a heat map that's tied to this risk index. Well, what might that look like? How difficult would that be? Well, it's really, so each of those states on that map is conditionally colored with a variable. And what I'm going to do is define the value of that variable by this thing I've defined as risk color. And let me go ahead and echo that down so we can see what it looks like. So the risk color is tied to that risk index. So if I scroll over here, I'll show you what it is. It's just a bunch of nested when statements. And what I've done is I'm going to say, well, if that risk index is less than 100, we'll give it the value 10. Now, what is 10? Well, 10 corresponds to white for a conditional color. Now, if that's not true, if the index is bigger than 100, but it's less than 150, we're going to color 12. 12 turns out to be gray, okay? And so on and so forth. Now, if you're wondering about these colors, I'm going to go ahead and show you. Let me go ahead and hit on this next page here. Just made a little color wheel here, and it's tied to this slider. The color 1, the number 1 corresponds to this dark blue. 2 corresponds to the lighter shade of blue. 3 is even lighter. 4 is green. 5 is brown. 6 is magenta, and so on. So this is kind of a reference for those colors. All right, now going back here, we've got this risk color defined. What I'm now going to do is color the states using that definition. So I'm going to define the list of colors for the states. See, there's 51 of them. So let me just do the risk color of the risk index. Of each state. So the states are really numbered from 1 to 51. 51 is District of Columbia, DC, and then the others are just in alphabetical order. So risk index of J, and we'll just have J run from 1 to 51. It's done. And the colors I chose was white for a real low risk index, gray for still fairly a little bit higher index, and then darker and darker shades of blue. The higher the index, the darker the shade of blue. Let's see how my map ended up looking like. Ah, there it is. Notice that it's been colored. There's 3 states that are white: Vermont, New Hampshire, Massachusetts. So they had those were ones that had an index less than 100. The gray ones have an index between 100 and 150. And then as these shades of blue get darker and darker, the higher the risk index. So you can see, looks like the southeast part of the United States has a really high risk index. You're thinking tornadoes or hurricanes, but it's a really neat way to visualize these things.
And Tom,
Yeah,
Tom,
go
notice,
ahead.
notice where Oregon and Louisiana are that showed up in the other data set that we looked at.
Ah, yes, interesting. Okay. And there's Utah is kind of standing out amongst the states around it. It's got a little bit higher
Right.
index than the others. Yeah. Now, what we've done is duplicate this map, and what will be, this is something that's real recent work we've been doing, and we're hoping to get a lot. There's lots and lots of data there. It's really tied and organized to the states. So we're hoping to do some more with that. Can't resist showing you a little bit more. Here's one that was just working on today. And this is, that was a heat map. This one is one of those choropleth maps. So we're going to look at categories of climate risks. And again, now I've got this blank map. And you see, I put a label there that says risk type. What does that have to do with? Well, let me go over to this spreadsheet. And this is the actually the same spreadsheet we had before, but I've added several columns. So for each of the states, I've put the kind of most prevalent types of natural disasters that have occurred within it. So if a state's been prone to drought, you'll see a 1 under drought. If it's not so prone to drought, you'll see a 0. So I'm just going to scroll over here, show you the different categories. We've got drought, earthquake, flood, hurricane, and tornado. And again, if the state is prone to that particular type of natural disaster, you'll see a 1 in that column. If it's not, you see a 0. Okay, so we have all of this data going. And what I've done is actually done the colors of the states. I've put it this time now into a math box. And the risk color is based on what type of risk, whether it's drought or flood or hurricane, and also for each state, whether or not it's actually prevalent. So let's go back to I think I tripped over my tongue a little bit there, but let's go back to the map, see if we can make sense of this. So I've got a little slider up here in the left. And what that's going to do is each type of natural disaster is tied to a risk type. And I'm going to make the risk type 1. That's risk type is drought. And what I've done is color every state brown that had drought as one of its risk types of climate. Let's look at a different risk type, earthquake. So these are colored in yellow. These are the states where earthquake has been identified as particular climate risk. Floods. And you can see some states have more than one risk type. Hurricanes. And this one was kind of surprising to me. Let's take a look at tornadoes. Wow, it's almost, there's fewer, almost all the states seem to be prone to tornadoes. There's just a few. I was kind of surprised that Arkansas was, made me wonder about the data a little bit. Okay. So
that's a really good question. That's a question a kid would ask, and then you would go follow up, find out what is the data right, or did they skip Arkansas for some reason?
So this is, by the way, the spreadsheet, if someone went in and just put entirely different data in this spreadsheet, they could redefine this kind of color scheme for the map, and it would update automatically. So we're hoping this is kind of adding to our technological tools, and especially because there's so much data out there that's organized by state, we're hoping that this will be an aid for students. So I'm going to stop sharing that.
Oh, wait, Tom, go back. You didn't show us where you would get all three.
Didn't get that implemented yet, Gail. But
Oh, okay.
okay. Yeah, that's on the list. Is we could look at ones, color ones where they have the multiple risks. Like I say, I was working on that just today. So let's see. Let's go back to the PowerPoint.
So there's been a couple of questions in the chat.
Oh,
One of
okay.
them was, why did I choose to use a linear model? Was there any motivation for that? The data were clearly, I didn't look at the residuals. The data clearly were not exponential or logarithmic. They didn't have any other pattern. Some of them had a linear, kind of a slight linear pattern. That would be a totally open to kids to try other models to see if they made sense. Another question was, where should we direct students to find the most accurate data? Unfortunately, there is no specific database or website. There are many, many different databases. And it's kind of like called web scraping, where you have to kind of spend a lot of time. That's one of the goals that Tom and I have, is that we will find and curate these data sets. So you can access the data that Tom has been using that I talked about for those 5 states. We've set that up in TNS files, and we've also made Word documents with those data sets in them so that you can access those data sets. We hope to add to the list of things that we do that with, so that you can have access to all sorts of different kinds of data sets that you can then just take and not have to go scraping around trying to piece ideas together, because it is not an easy task to figure out where you can collect all these data from. Sometimes you even get conflicting data, which is not a surprise, and you have to try to track it down. And sometimes there's like, well, maybe Arkansas did get left off, and you have to figure out what's going on there. So unfortunately, there's not just one place you could get the data. You guys wish they could do that on the 84? Like I said, you could do the census at schools on the 84. That works. You could do a little bit of the risk data that Tom was doing, but you can't do the map. The 84 is just too limited in it. And if you try to put much more than maybe 200, but maybe it really works best with just 100 data values entered in. If you try to do too much with any more than that, it slows it down until it's really kind of awkward, running very, very slowly when you use that on the handheld. So the Nspire is much more susceptible or friendly for working with these large data sets. Although you can do the programming on both of them, which would be a help to some of the things.
I was going to add, Gail, that the data sets that we found that are particularly interesting, whenever possible, we do try to put those onto the TI-84. What it involves often is a little program that basically then just loads the data into your lists. We've found, I think we believe that one of the impediments to teachers doing more with data in the classroom is just the overhead in terms of getting the data onto the machine. So part of what we've been doing is creating TI-Nspire documents that already have the data in the spreadsheet ready to go. And similarly on the 84, you can make a program that basically loads the lists into your list editor, so it's ready for you to use this really nice statistics functionality that's on the 84.
Yeah, yes. And some people are like, they're using the 84, and the 84 is an awesome little tool. As a matter of fact, some of our simulation work we have done on the 84, and the ProbSim app is one of the best simulators that I've seen. So the 84 is actually a really nice, powerful tool. It just, for large data sets and speedness, the Nspire, it really can do that much better. And we're still worrying about the scatter plots, modeling those functions, and I would agree. And you might, kids might want to think about some other ways to do that, or some other ways to transform the data. So there's no kind of hard and fast rules about what you should be doing or should not be doing with these different ways to think about analyzing that data. So it's one of the places where kids discover stuff on their own. They discover stuff about the functionality of the technology that they're working with, and they get excited about it. So even if they don't go much beyond the box plots and start to understand what those box plots look like when they look at some of those things, or know when they can use box plots and when they should be looking at some kind of an association, if they can get to that point, they're way ahead of the game. So that's great. So going back, this was one of the surprises to me. One of their factors that they have in the risk, I don't know if you noticed that, was the mosquito growing season. Coming from Wisconsin, where we have a lot of mosquitoes, that was pretty interesting to me. And this year we didn't have hardly any mosquitoes, so I don't know. We'll have to add that data point. Next slide, please, Tom. Oh, and this was just some of the exploring some of the things that you could do just on the with the risk data before you actually went to look at what it looked like in the States. And you saw what that Tom was clearly showing you, that what he has been able to accomplish. So there are a bunch of states in the yellow there that are all stacked up in the yellow and the magenta that have 3 of those disasters in there. The magenta has 2, but so it kind of like helps you get a understanding of some of the things that that was feeding into those risk factors that Tom was showing you across the United States. Next slide, please. Here's wildfires, the relationship between wildfires and drought. Wildfires, so that's another, it's kind of interesting. We didn't put this in there, but the number of wildfires has been decreasing, but the severity of the wildfires has been increasing. The amount of acreage burned. As a matter of fact, you notice that one picture on the left there. We had to take California and Arkansas out, or Alaska out, because they had so much burnage that it was just like an outlier. Ordinarily, kids would look at that and say, well, there's something wrong. I should probably get rid of that. But this kind of interplays with the map that Tom was showing you, where you can see that the states that are prone to drought, although it was kind of interesting, there's a bunch in the Midwest that are prone to drought as well. Michigan, Wisconsin, as well as some of the ones that you would expect. Washington, Utah, Colorado, California. So it's kind of an interesting. Next slide, please, Tom. Feel free to post any other questions or anything that you want to are curious about or want to comment on. So Tom mentioned that there's heat and human costs, and so that's factored into some of that risk data. So in the states that you can see that the fire affects a different range of states, percentages of people across the state. So some states, there's nearly 80% are at risk for fire in some states, whereas in other states, there's not that much risk. Only 10% of the population is at risk. I think the heat vulnerability, that's very much tied to age. So if you have an aging population in a state, the heat vulnerability, or if you have large urban areas like Chicago or LA, where it becomes very, very warm and the elderly have no way to move around or to leave where they're staying, that also contributes to this risk that they have. So this is another whole dimension of thinking about risk, is what does the risk do to the human people, what's its effect on human lives. Next one, 2-minute warning, Michael says, okay. So one of the ways to get a model for this is, and this is what the people that did the risk factor did, they just added them all together. They ranked them from best to worst and added them together. The next slide shows you the outcomes of that. So Florida is the riskiest state to live in, given all those factors that we were looking at, followed by South Carolina, Louisiana, keeps showing up here, North Carolina, and Mississippi. The safest states are Hawaii and Alaska, according to those risk factors, and the ones that Tom had identified, Vermont, Massachusetts, or New Hampshire, those are pretty risk-free states. Next slide. So we've done that. Next slide, next slide, next slide. We'll wrap it up. So why should data science be, back up one, please, Tom. So why should it, so kids get really excited by data science. It's really a cool thing for them to get involved in. And it actually spans a lot of things that we want kids to be able to do. Arguing from evidence, engaging in long-term investigations. I like this idea about supporting long-term learning than just unproductive immediate success, helping improve critical thinking. All of these things are byproducts of when kids are engaged in data science, aside from the fact that they get really excited and motivated. Next slide. And so there are ways that you can incorporate these data science activities into your classrooms. They're great alternative assessments. They make great ways to present things, what kids have been doing in class, to families. A lot of people are thinking about data science as a course that's an alternate to a calculus pathway. There's really rich learning that can go on that will actually carry over as kids transfer to college or post-secondary institutions. So there's a lot of kind of pulling together some of mathematical ideas, especially very basic ideas like percents and relative frequencies. Last slide, I think, Tom.
Okay.
And so here's where you can get the activities. Many of them, what we're working on now is not up there yet, but there's a site both for the 84 and for the Nspire that contains these activities. If you guys would like to hear more about these kinds of things, as Tom finishes up that last one and we keep adding different kinds of data, let Mike know, and we can offer some more things to share with you. Love to hear from you if you have any questions. Turning it back to Mike.
Thanks so much, guys. Yeah, as Gail just mentioned, we are going to be wrapping up here in a minute. And when we do, you'll automatically get a follow-up survey that will appear in your browser. And that survey really helps guide us. We're going to take a little break here for the rest of the fall. We'll start back up in January again, give everyone a chance to recharge their batteries. But trying to plan future events that are going to be exciting for everyone at home. Feel free to share your thoughts in that post-webinar survey, things you like, things you want to see more of. That kind of information is really important to us. And we also, so that we'd be giving away to one lucky winner tonight, a TI graphing calculator. And tonight's lucky winner is Otto Acon. So Otto, congratulations. We'll be reaching out to you in a couple days to get some information over email from you. To receive a certificate of attendance, go ahead and click the link in the chat window. And also this is a link for the documents tonight from Gail and Tom. And let me try and make this a hyperlink. Sorry, I thought it was ready to go. Let's try this again. There we go. And if these links aren't working for any reason, just hang tight and you'll automatically get a follow-up email in a couple of days, and that follow-up email contains links to the recording, the documents, and their certificate as well. If you're watching this on demand, copy this link into your favorite browser to receive your certificate. Huge thanks to Gail and Tom. I know that it took some time to not only find data, but to go through and pick through good data to use and to enter data. Like that just, I know, takes an exuberant amount of time. So thanks so much to both of you for all the time that you spent getting things ready for tonight.
That's
Thank
great
you, Mike.
fun. Thanks, Mike.
And thanks to everyone for joining us. Again, have a great rest of your 2022 year, and we'll see you back in 2023. Have a great night.